The topic for today is going to be descaling Agile, or kind of actually figuring out how do we apply something that resembles Agile to large organizations. This is organized by TechTalk, and I love working with them because TechTalk is one of the best Agile consultancies in Austria. So, kind of at the start, because I only have 35 minutes, I'm going to waste a few minutes of that time by getting Robert to actually kind of show us pretty much the most important thing you can see today about running Agile in large organizations. So we need a couple of volunteers, and you volunteered. Marcus, I'm going to volunteer you as well, and you are going to do this as well. Yeah, so this is kind of the most important thing you can learn about running Agile in large organizations today. Yeah. Good.
Okay. Let the three men on this side, please, with their partners opposite them.
Okay.
You want me to explain what I'm doing?
No. Just tell me what to do.
Tell you what to do. Okay. This is the Scottish country dance.
I intend to.
Scottish folk dance. Okay. The music would be up that end if you were dancing. Everybody take your partner with the right hand, turn them all the way around with the right hand back to your own place. Back to your own place. With the left hand, all the way around. Back to your own place. With both hands, all the way around. Back to your own place. Now you do something, those of you who speak French, don't see no. Back to back. You go past your partner, back to your own place, back to back. Okay, now, this is where it gets interesting. The first couple goes down to our place and makes a bridge. We follow you. So you go down the side,
Okay.
down the side. We come up, pass down the sides, go down the side, follow them. Make a bridge. We come down, go under the bridge. You guys just go under the bridge.
Okay.
And we are here, and now, we are now in positions 2, 1, 3. We've changed places. Yeah. And the dance would keep going like this about another 8 times. Yeah, till you fall over.
Okay. So we're not going to get people to follow. This was absolutely amazing. Thank you for teaching us how to stay right like this together. Okay. So thank you very much. Now I've wasted 10% of my time exactly like this. And the reason why I wasted this is I want to tell you a story about a client that I worked with about a year ago. It was a small fintech company. What I mean by a small fintech company, they only had about 120 developers. They organized them in, I think, about 6 teams. And they were doing, some horrible variant of some scaled Agile methodology because it's a financial company, so you have to have a serious process. And there was a lot of this ceremony where nobody understood, why. And they were moving around. It was really, busy and things like that. And they had this big problem because somebody told them that each team has to have their own KPIs, and each team has to have their own roadmap, and each team has to have their own goals. And 2 out of these 6 teams were kind of infrastructure teams that couldn't really deliver value on their own, but the other 4 teams couldn't deliver value without infrastructure teams. And because they all had their own roadmaps and their own goals, they were constantly locked in this battle. Should I work on my goals or should I work to support their goals and things like that? And it was like completely insane watching what's going on. And they were doing that because that's their process. And that's how they need this. So when I started looking at this, it was really strange because that's not how smart people solve complex problems. These people were reasonably smart. They work in fintechs. They had a really complex problem, but what they were doing is like this really complex routine that people were following over and over, and they were congratulating themselves for being better and better at the routine. And that's not a software process. That's more kind of, why is this not working? So, has nothing to do with software. So it looks amazing. It looks absolutely amazing. Everybody's engaged. Optics are great. But not a lot of software gets delivered. That's the problem. But one of the nice things about this is that you can scale it almost indefinitely. And you can hire two people, you can teach them how to do this, you can get TechTalk to teach them how to do this. And there was, you know, there was I know there's a kind of rivalry between South Tyrol and Bavaria doing this stuff. So in 2014, in a place called Antwerp, they got 2,000 people doing this. So what you'll notice with a larger group of people here, first of all, the music is a lot slower. Because they cannot coordinate. The second thing is, they're not that well rehearsed, you know, people are jumping around. It's not that nice. But the third thing that was really, you know, interesting is, they are not more enthusiastic than a smaller group. They were congratulating themselves just for being able to pull this thing off. And that's what I see in larger organizations very, very often. They kind of congratulate themselves just for being able to pull off this process on a large group of people. It doesn't really matter what the outcomes are. And this is kind of, you know, it's totally insane. We're getting to the situation where people are applying these really complex processes just for the optics of it. And we need to kind of start doing something different. So the big question is, I think, how did we even start getting there? And because what I see is this dance is getting more and more complicated over the kind of last 10 years. And there's a guy called Parkinson, famous for Parkinson's law, who in 1955 published a research based on British colonial bureaucracy. And he concluded that, you know, regardless of whether there is work to be done or no work to be done, bureaucracy tends to grow around 5% a year. He published this thing in The Economist where, you know, the numbers are a lot more precise, but it's kind of around 5% a year. So what that means is really doesn't matter what we do, bureaucracy goes. And there was a really interesting kind of research based in US universities published in 2014, because 50 years ago, admin staff was a minority at universities. Teaching staff was majority. In 2014, they concluded that there's at least 2 times more admin staff than teaching staff. And most of the admin staff are permanent employees, where teaching staff are getting put on contracts, they're getting put to be temporary employees, because kind of bureaucracy grows 5% a year. Let it grow over 50 years, it's, you know, we destroy everything. So, you know, the original Agile book, XP Explained, was published in 1999. We have, you know, almost 20 years of bureaucracy growing. And you can see that very easily. Kind of the original Scrum guide, you can still find the original version of which this website is 13 pages long. 13 pages long. The book called Essential Scrum is 427 pages long. But no, let's not stop there, because there's a safe reference that's in bureaucracy grows 5% a year. That's the problem. We make this dance more elaborate, more complicated, we make bridges, we make these, you know, round trips, and then we pride ourselves on being able to dance a more complicated dance. Please, let's stop doing that. So, Parkinson is famous for Parkinson's law, which lots of people interpret today as the work will expand to fit whatever capacity you have. So if you have 500 people, you will find work for 500 people. If you have 20 people, you will find work for 20 people. If you have 6 months to deliver a project, you'll deliver a 6-month project. If you have 3 years, people will find features to deliver in 3 years' time. Now, Parkinson's law is a bit misquoted. The original Parkinson's law in this article is not that the work expands to fit the capacity. It's basically that officials make work for each other. And that's how bureaucracy grows. Or if you want the Agile version of that, so that's kind of the problem we have. And it's gotten so bad.
Take that personally. Possibly true.
So this thing has gotten so bad that it's getting militaries of the world worried about that. This thing is going to cause the Third World War. I'm not joking, the people who invented waterfall, the American Ministry of Defense, last year published a guide on how to spot agile bullshit. It's gotten so bad that the American military is worried about that, and they have a guide for their people how to spot bullshit consultants that are trying to do bullshit agile with them. It's absolutely amazing. I was really surprised that something published by the American military is actually, amazingly spot on. And I strongly recommend downloading this. You can download this from this URL and read it. But the big question I have in my head is why on earth did we get there? How is it possible that we got here? In just the space of 20 years. We had people over a process 20 years ago, and now we have 800 pages of process that basically kills any innovation. How did we get there? And there's a couple of explanations for that. One explanation for that comes from chemistry. There's a guy called Henri Lachatelier, who was a French chemist in late 19th century and early 20th century, and he was famous for formulating this principle of equilibrium. He says if you have a complex system that's in some kind of equilibrium, and there's a movement in that system to kind of disrupt the equilibrium shifts back to negate the movement. Or if you want kind of a more software or organizational version, there's a guy called John Gojko who published a systems thinking comedy book called Systematics, in which he says this is basically a large system at some point tends to oppose its own proper function. You have this thing that's designed to deliver better software, it's actually fighting with delivering software. And it's not an uncommon thing at all. It's something that you can see with very, very large systems, and the reason why is that at very large scale, the relationship between cause and effect is no longer that clear. When you have 2 or 3 people involved, you can kind of say, well, he tried to teach me how to dance, but I'm clumsy, so I cannot dance. There's a relationship between cause and effect. Or, he was teaching me how to dance for a whole week, so I'm a bit better. Again, but with a large number of people that they all do their own things, and there's a lot of dependencies, the relationship between cause and effect stops working. And that's why kind of a large system sometimes looks like it's opposing its own function, because this becomes counterintuitive. So the building it back is very interesting. It's the space vehicle preparation shed at Cape Canaveral in Florida. So shed for me usually means some small thingy where you keep a pipe, but in this case it means where you keep large rockets as people are preparing them. And this thing is famous for being the largest building by indoor space in the world. They built it to protect rockets as they're being assembled from rain, from bad weather and things like that. And the irony of this thing is that when it was built, it was so big that it started generating a local climate ecosystem. So it started gathering clouds inside the building, and it kept going rain. That's how big it was. So it was built to protect rockets from rain, and it was generating rain even when there was no rain outside. And that's why we get with kind of a very large system. It's very deep. Even NASA, even the smartest people in the world cannot predict what's going to happen. And this is, you can see this in modern software processes all the time, where a system tends to find its own function. Kind of a large system tends to push back, to go back to an equilibrium where it was before. So this is an actual job post from Total Jobs from the Capgemini Financial Services UK. You can find it on this URL. It's a Scrum Master job post that requires people to deliver expected cost and quality using, Agile and Waterfall, to take prime responsibility for matrix resources, whatever that means. And then to, manage budget and work orders and stuff like that. So, what this has to do with Scrum Masters, I have no idea. I want to apply. But, we're getting this. We're constantly getting this stuff where, hey, we had this kind of guy who was a project manager before working as a Scrum Master. Yeah, why not? Or, he was a business analyst, but he's a product owner now, and things like that. And this is where Marty Kagan published a phenomenal article I strongly recommend you read on his website, where he talks about how SAFe is actually a revenge of the project management office. SAFe is basically embrace, extend, and extinguish strategy against Agile, where kind of they're starting to use the same terminology to just confuse everybody, and then basically keep whatever they were doing before, but being Agile now. And that's what we got 20 years after people over the process. Horrible, absolutely horrible. So, kind of, but at the same time, we had 20 years of industry experience here, at least now, and there's even before that, when these processes that got distilled into XP and Agile, so we have 30, 40 years of experience doing this stuff. And there is there are organizations that scale software delivery really well. So about 3 years ago, I failed to write a book about that. Because what I wanted to do is I wanted to actually interview people who do this really, really well. And I wanted to see what do they do differently from other people and what's common about what they do. I wanted to look for patterns. So, for example, one of the things I was really interested in is at what point do we switch from a single repository to multiple repositories to manage source code? Or at what point do people switch from multiple repositories to a single repository? Because there's some really weird data out there. For example, the entire kind of Google code base for search and everything is in a single repository. Microsoft migrated the whole Windows code base to a single source code repository. There's kind of some other reports on that, but at the same time, there are other organizations that are doing this other things. So my assumption was that when you have a very small team, a single repository is really good regardless of how many projects you have because it's a very small team. And then at some point, people start kind of trampling on each other's changes and it becomes difficult to manage, so people break it down into product repositories, component repositories, and then at some point that becomes difficult to manage, so people join the single thing. So I wanted to find these two boundaries. And the more I spoke to companies, the more I realized there is no pattern. Because some people were telling me that they were using multiple repositories for exactly the same reason why other people were telling me they're using a single repository. And kind of there was no pattern, and the more I was talking to them and trying to figure out why, they were saying like, oh, we tried this thing, it didn't really work for us, so we tried this other thing, it worked better. And basically what I realized is there is no pattern, but there's a meta process there. So most organizations that ended up with a large-scale delivery that was successful, they started somewhere simple. They didn't start with a really complex process because a really complex process is difficult to do correctly. You end up doing the dance. So they started with something simple, and then they kind of really honestly evaluated the current state. Like, okay, we are using multiple repositories, does it hurt? If it hurts, let's do something else. And kind of they adjusted this thing until it stopped hurting. And then basically what they did is they automated as much as they could everything that's preventing them from going through this kind of cycle, and just repeat. So I realized if I'm going to write a book on how successful organizations scale Agile, basically does this line. Because there is no more advice without having it contextual. And if I start giving people very kind of low-level contextual advice, maybe it's not going to apply for their context, and I'll end up with 800 pages of shit that worked for somebody and didn't work for somebody else. So I'm not saying that any of those books are bad. I'm saying that those books are collections of ideas that worked for other companies in their contexts. That might or might not work for what we need to do. And this is why I really love Craig Larman's work. Craig Larman's books are pretty much on, if you're in this situation, try this thing. It might work or it might not work. And that's it. There's just a bunch of ideas to try. It's not a prescriptive process. So, here we go back to kind of the Department of Defense and what they concluded. And I think, if there is a book on scaling Agile, it's pretty much the Department of Defense report. And what you find there is a bunch of questions to ask people, like, what is your testing strategy? And then they have the wrong answer, but they don't have the right answer. They say, if people tell you we have a separate testing organization, that's wrong. But then, there's no right answer, they find something else. So they're exposing things that hurt. So the Department of Defense I can read the article, but here's a couple of flags they pointed as something that is kind of fake Agile. The first thing is that nobody on the software development team is observing this in action. People that develop software are disconnected from people who use software. The other one is that feedback from users is not continuous, so it's not available. And About 2 years ago, I've done this survey online. I've asked about 1,000 people to fill in from lots of different teams how frequently they observe end users using their software. More than 50% of the people that filled it in have never seen a user in action with their software. So the third one is that meeting requirements is more important than kind of chucking something useful on production as soon as possible. And the fourth one is that manual processes are tolerated where they really can and should be automated. So I'm not advocating automate everything, but stuff that can be automated really should be automated because it's just slowing down people. It's wasting time on what people need to do. So, there's a famous quote from John von Neumann, where in the 50s he was approached by a kind of colleague proposing that they get a few students to build an assembler. Because they were kind of chucking ones and zeros into the machine to work. And they said, like, why not come up with, some, mnemonic system and we can develop something higher level so we don't deal with a really low level machine language. And John von Neumann, the genius, replied that basically expensive scientific equipment shouldn't deal with medical tasks, and threw the guy out. Now, we no longer work with this expensive scientific equipment. Computers are cheap. Our time is expensive. They should be doing medical tasks, not us. So, effectively what all these things say is feedback loops remove agile pushing. That's kind of the essence of all of these things. So, what I mean by that, it's really important to understand feedback loops, kind of stuff coming back and influencing what we do. And I started researching this stuff a lot more because I'm interested in the science behind feedback. So feedback systems are actually part of something called control systems theory that has emerged somewhere during the Industrial Revolution when people started building systems that were so complex that cause and relationship, cause and effect relationship no longer worked. So we have 150 years of scientific research here. Then kind of during the early analog electronics era where the manufacturing processes were not reliable. People were building vacuum tubes, they didn't have reliable outputs and stuff like that. These things got a lot more attention because feedback systems, proper scientific feedback systems allow somebody to create redundancy in case of uncertainty, create reliability in case of uncertainty, build robust systems, create robustness. So create something predictable out of something we cannot really understand, which is what we're trying to do with logical systems. Now, if you go and research feedback systems, I'll give you a couple of books on this. You usually find lots of kind of really weird diagrams like this and graphs and stuff like that, but they have loops. They have stuff coming back. They have one system influencing something else that's kind of influencing us back. And even the first software system ever that was commercial did this because we had software people building something, then clients being disappointed, and then software people had to change the software, which is kind of a loop. Now, the most important thing about this thing is kind of that there are loops here, and lots and lots of software teams, especially this kind of financial company I work with, they cut the loop. They organize the feedback process, they do retrospectives, they collect the data, but then they complain how this thing is not working for them. Because they did not act on the problem. Whenever people tell me Scrum is not working, we still have all these problems. I'm telling them Scrum is working, Scrum is a mirror. Scrum is showing you that you have problems. It's up to you to fix them. You need to have the action there. So, kind of the number one thing I think is to look at the scientific principle of feedback. And this comes from a book called Feedback Systems by Asper and Murray, and they define feedback as basically a corrective action on the difference between design and actual performance. That's the scientific definition. And there's a couple of elements to that we are really, really bad at in software teams. First of all, we do not know what the design performance is. And we do not know what the actual performance is because we don't know how to measure performance. And the third thing we are bad at is then listening to that feedback and coming up with some corrective action. I consulted a company about 2 years ago where they asked me to audit if their agile transformation succeeded. Which is totally bizarre because the technical people and the business people were in a conflict when the Agile is working. The tech people were saying that they're doing everything amazing and it's all by the book, and the business people were saying how it's even worse than before because nothing's coming out, or the right thing is not coming out. And I met with them, and one lady from the business side said, we feel that as a company we're a lot less productive now than before. And I said, how would you know? She said, what do you mean? Well, how productive were you before? How productive are you now? Like, unless you measure, you do not know. It's kind of, all this stuff with feedback is really challenging because we cannot implement proper feedback loops without knowing them. And that's like, having a shower without a thermostat, where, you flip it and then really hot water goes down because you have no idea what's going to happen. So, another really interesting thing, if you look at the science of feedback and control systems, is they talk about two primary types of control. One is feedback, and feedback kind of essentially, if you try to do feedback without the loop, it's just bad news. And that's what lots of scale things do. We have this process that is supposed to measure stuff, but people just get the best. Now, the other type of control that kind of they talk about in the science of control systems is feed-forward. Now, feed-forward is the opposite of feedback. Feed-forward is one system influencing another by giving it exactly what the other system. It's giving the commands to correct an error without really measuring anything. So, a really nice example of that is when you go to a doctor and you say, look, I have, my head hurts, I'm vomiting, all of this stuff, and the doctor looks at the symptoms and says, okay, take this pill 3 times a day for the next 2 weeks, you're going to get better. In most cases, you will. And the reason why a doctor can do that is that we have 5,000 years of data on killing people with random mushrooms and plants and things like that. And then we have now clinical trials and all this stuff that's supposed to measure and model the effectiveness of a pill, how much you need to take based on your body mass and things like that. So feed-forward is great if you have the data. Feed-forward is great if you have accurate models of what's going to happen. If you don't have accurate models of what's going to happen, then feedback is much more simple. And that's the benefit of feedback over feed-forward. You can implement something that's reasonably simple to control a really complicated. You just need to measure the error and kind of do something to activate and do it quickly. So, the really interesting thing when we start thinking about copying a process is that this is not medicine. Copying a process without the data is witchcraft. And that's why kind of, people implement this rather than anything sensible. So, now, the feedback and feed-forward are not mutually exclusive. Actually, in a good control system, we need to mix the two. We have some data, we start somewhere, and then we kind of iterate and improve. And basically, the problem with that is that feedback is really difficult to pull off. I'm not claiming that I'm an expert on this stuff. There's 150 years of scientific research here. I've read a couple of books, but there's some really interesting points I've taken from these books about actually implementing good feedback. And they say that there's a couple of typical failure modes for kind of feedback systems. One is there's an overhead of measurement, especially to measure important things. Douglas Hubbard in his book on how to measure anything says that it's very, very kind of lots of companies measure shit that's easy to measure, not what's important, because we are afraid of the overhead of measurement. So we measure story points. Who cares? Really, who cares? And we measure kind of stuff that's easy to measure, but it's not really helping us reduce uncertainty about whether we're doing the right thing or not. The other kind of problem here is that mathematics get complicated. I have a bachelor's degree in mathematics. I finished university in 2002. I tried to read the mathematics in these books and it was totally, not understandable. So as soon as you start getting into real kind of physical feedback systems, math gets really, really crazy. And that explains some interesting failure modes when people do trivial mathematics with story points, like, oh, you know, we've collected 50 story points now, I'm going to multiply, I'm going to divide, I'm going to add some things. So no, it just doesn't work like that. Math is a lot more complicated if you want to get it right. The other thing that kind of often comes as a problem is sensor noise. If we're not measuring rightly, if I'm measuring the temperature outside to control kind of the air conditioning in this room, it doesn't make any sense. And a lot of people actually do that. They measure a shit that doesn't matter. And then kind of the next thing is that if we don't have a good control of this, we can get a runaway process. We can get people going too far, doing something too crazy, failing in some weird modes, and there's a kind of, that's the aspect of that explains basically this company where you have people who say we're doing Agile the way it works and have, you know, we're not productive anymore. It's a runaway process. People know a process led to a runaway process. And the last really important thing here is that with feedbacks, delays cause oscillations. I had the pleasure of listening to my children learn how to use an instant shower this summer. Instant heater showers, ironically, are showers that do not heat up the water instantly. They heat up the water as it's going through the pipes, so it's kind of an engineer-led thing. There's a shower with a storage tank where you have hot water, you turn it on, it's immediately the temperature. With an instant heater, you say I want water, but it takes a couple of seconds to warm it up. And if you don't know that, kind of there's a delay, then you like my children where you say, you know, they turn it up and then it's not hot enough, so they turn it up even more, and then a couple of seconds later you hear, ah! And then kind of, you know, they dial it down, but it's still hot, so they dial it down even more, and then it's really cold and it's, ah! And then, so feedbacks cause oscillations. And you can see this with lots and lots of software teams where the business priorities change. How is it possible the business priorities change every 2 weeks? That's insane, the business didn't change that much, but we have delays in feedback that are causing, oh, now we're focusing on enterprise customers. No, forget that, we're focusing on, you know, small users. No, forget that, we're focusing on New Zealand this week. Or, you know, so that's basically what's happening here. So, one of the things that books about feedback systems also talk about is different feedback systems where you have conservation laws. For example, water has conservation laws for temperature. So if the water is really hot and you turn on the heating, it doesn't get to minus 100 degrees next second. It goes gradually. So when you have conservation laws, you can apply good math. When you don't have conservation laws, pretty much all that math goes down to it. In human behavior, we do not have conservation laws. Somebody can be really happy now, tomorrow they can be really happy. This team can be working phenomenally now, tomorrow they can be completely blocked. There's no conservation there. So any kind of math we try to apply, it just goes outside the window. And the problem can be solved, or kind of, you know, the science of feedback tells us that the only way to solve this problem is to kind of shorten the loop. Get feedback as fast as possible so that we can act as quickly as possible on this. So, kind of to finish this thing off, I have 2 more minutes. I want to kind of give you 4 key steps to scale Agile. So the first step is really start somewhere that kind of works, that's kind of simple. Don't start with the complex process. Because if you start with the complex process, you're going to waste a lot of time trying to learn the dance, and you really don't need to learn it. Because that's not going to be the final version of this anyway, because somebody else's dance doesn't work for you. And the next step is kind of measure the error. Figure out what the error means and measure the error somehow. And don't shy away from this thing being expensive to measure, difficult to measure, because it's really important. Now, the next step after that is act to reduce that error and close the loop. Really close the loop. Figure out, kind of, if you're doing retrospectives, don't complain about the same shit every day, do something about it. And the last step is loop, basically, that's it. Now, the acronym here is small, with only one L. Somebody's going to say, you know, Gojko doesn't know any English, this is not how you spell small, so to make it easier to remember for you, kind of put 2 L's there, basically, just say loop at the end. Now, one really important aspect of this, and this is where lots of people are going to get stuck, is how do we measure the error? What do we mean by productivity? And for a lot of people, that's going to be challenging, especially for large organizations. And in large organizations, weird shit happens. This is an actual way how Boeing measures productivity from their description of their Agile process. So I don't know of a worse way to measure productivity, but you can see that this is what kind of, a brilliant example of people measureship that's easy to measure, not what's important. So please don't do this. Kind of create a meaningful goal for process improvement. And here's a couple of examples. I worked in a bank where, in the back office department of a bank, we defined the purpose of the department is to reduce the cost of transactions. It's the back office part. So the better they do their work, the cost of transactions goes down. Now, cost per transaction is something to measure. Number of cases per day, number of stuff per day that people can do is very often a useful measurement to supporting a service organization. This is an example from Mark Schwartz's book on the art of business model, where you apply this in a large government organization, huge US government organization, where they were trying to re-engineer the software process. They looked at how many cases can a case worker process per day, and if they do better software, a human can process more cases. Some other kind of less businessy measurements that people often use are flow and throughput and cycle time. And that again comes directly from the feedback systems theory, where they talk about how with complex systems, looking at inputs and outputs is pointless because there's no relationship there. The best thing you can look at is analyze the flow of information and then optimize that. So thank you very much. I ran out of time. Hopefully this took us your imagination a bit.